Hi, welcome to another session of Circuits and Networks. In today's class, we are going to see electric circuits problems and solutions which were asked in GATE 2024 under ECE exam. So you can see here we have two different problems which were asked in 2024 for 1 mark question, and directly it was a fill in the blank type of problem. So how to solve this kind of problems we are going to see in today's session. For that, you can see in the first problem, uh, in the given circuit, the current Ix in milliamperes is dash. So we don't know what is the exact answer. So we have to solve this particular problem. For that, what we are going to do, we are going to assume two node voltages V1 and V2 over here like this, and then we are going to apply KCL for the supernode. Now you can ask me what is exactly supernode. Whenever you have a dependent or an independent voltage source shared between two nodes, then it becomes a supernode. Hence, according to the given problem, we can write V2 minus V1 is equal to 1000 I naught. So this is our first catch in this problem. Okay. After that, we need to know what is I naught. I naught is the current which is flowing in 1 kilo ohm, which is exactly equal to V1 by 1000. 1K is equivalent to 1000 ohms. So the current I naught, which becomes a branch current, it will become as voltage V1 divided by the resistance 1000. So these are the two important, in fact, we call as observations by looking into the problem. Then applying KCL at node V1 and node V2 together. Why? Because we are following a super node analysis. For that, minus 5 milliamperes of current which is flowing towards node V1 plus V1 by 1000, that is the two branch currents which are applied to node V1 apart from the super node concept, and we have to take the other node also into the consideration, that is V2 by 1000, that is nothing but the current Ix, which is also a requirement. So it becomes V2 by 1000 plus Y plus, if 5 milliamperes comes as input and 2 milliamperes goes as output, so I can treat one as negative and one as positive. So based upon that, I have framed this equation 3. Now solving equation 3, it resolves into equation 4 like this. In fact, we have V2 minus V1, which is nothing but substituting equation 2 in equation 1. We are going to get the value of V2 as 2V1 as equation 5, and with the help of equation 4, if at all you substitute these values, you are going to get V1 equal to 1 volt. We are framing at equation 6, and V2 will get as 2 volts, which we framed as equation 7. Then it is easiest to find out the value of Ix, which is nothing but V2 by 1000. So in fact, we are going to get this current which is flowing in 1 kilo ohm as 2 milliamperes. So this is how we need to solve the problem for blank questions. In fact, fill in the blank type of questions. So this is the right answer. Another question which was asked in GATE 2024 1 mark is the value of time constant once the switch position is changed from uh, open circuit to closed circuit. Okay, so you need to concentrate on the source which is given to us. Here we have 5 amperes, and you have the parameters which is nothing but inductor and resistors. So once you close the switch by removing the current source, you're going to get the new circuit like this. Now we need to find out the time constant. What you have to do is that you have to calculate the L equivalent as well as R equivalent. Means what? What are the inductor values are given? What are the resistor values are given? You calculate the total inductor values as well as the resistance values. So once you close the switch and remove this source current, you're going to get L equivalent. We have only one inductor whose value is 3 henries, and we have resistance where you can see 4 and 4 are in parallel and the combined value is in series with 2. So hence R equivalent will be equivalent to 4 ohms. Therefore, time constant for RL circuit will be given as L equivalent by R equivalent, which is nothing but equivalent to 3 by 4, and it becomes 0.75 seconds. If at all you concentrate in GATE 2024 electrical paper also, this type of question was asked. In fact, almost if at all you look into 5 consecutive GATE exam papers, these type of questions were asked where we need to concentrate on time constant, whether it belongs to RL circuit or RC circuit. Fine. Let us go with the next problem, which was asked for 1 mark under GATE 2024 for EC paper. We need to find out Y21. It means the reverse transfer admittance parameter for this circuit. Okay, we have many methods to find out the solution, but we'll stick on to the Y parameters. So first, what we'll do, we'll take the port 2 dash and we'll short circuit it. So while short circuiting this particular port, let us assume two loop currents as IA and IB. So IA and IB are assumed like clockwise direction of currents, and you know the admittance parameters which are given by this standard equation I1 I2 in terms of V1 V2. And what we need to keep in our mind, we know that I1 is equivalent to IA, which we have assumed current in clockwise, whereas I2 is equivalent to minus IB, and this I'm treating as equation 1. Done. So this is our first assumption. Then from the two port networks under Y parameters, we have this standard matrix formula. With this I can derive I1 in terms of V1, in terms of Y1 as Y1 equal to I1 by V1, whereas Y21 is equal to I2 by V1 at V2 equal to 0. So these two parameters can easily derive once you short circuit the port 2 dash. Okay, these are the basics you are supposed to know before solving this problem. Anyhow, applying KVL to the loop, what we have assumed as IA and IB. So I'm applying KVL to loop IA. I'm going to get the equation as V1 equal to 6 by 9 IA minus 4 by 9 IB. Fine. So this I'm treating as equation 2. Then I'm shifting my attention to loop 2, where you have 8 V1 and 4 I2. I said in fact IB minus IA. So that is what I'm doing over here. And I'm reframing this equation as IB equal to IA minus 2 V1 and framing as equation 3, and substituting equation 3 in equation 2, I'm going to get V1, which is equivalent to 2 IA. In fact, Y1 will be equivalent to I1 by V1 because IA is equal to I1. Hence, the value of Y11 will be equal to 1 by 2 Mohs, or you can say Siemens. Fine. So this is not our requirement. Our requirement is Y21. For that, what I'm going to do, I'll take the help of equation 3, where you have IB is equal to IA, where IA is nothing but we got just the value of I1, which is nothing but V1 by 2 minus 2V1 from equation 3. With this, I'll get the value of I2 in terms of Y21 as I2 divided by V1 equal to 3 by 2 Mohs, or Y21 equal to 1.5 Mohs. So this is how you need to solve for electrical circuits and networks for interdisciplinary courses or electronic related courses. So I hope you like this particular video. Please share among your friends, subscribe to this channel, and please press the bell icon for new future notifications. Thank you.